In exercise 10.05, we're going to have a look at the concept called the cumulative frequency and then the graphs. There are two graphs for cumulative frequency, the histogram and the polygon, and we'll talk about those in a moment. So, to get started, what is this cumulative frequency? Well, the cumulative frequency is, just as it says there, a running total. It keeps count of how many scores we have at any particular time. It's how many scores we have, not the value of the score. The value of the score is in the first column of our table. These are our scores. Our scores range from 12 to 21. You can see our cumulative frequency ranges from 1 to 30. This 30, our last cumulative frequency entry, tells us how many scores there were altogether. So after I've listed the 12s, then I've only got one. But after then listing the 12s and the 13s, I've now got 3 scores. If I was to list the 12s, the 13s and the 14s, I would have 9 scores, and so on. And it then stands to reason, if I've listed all the scores down to 21, I have a total of 30 scores listed. Now, previously we've either used the calculator or by hand. We've arranged our scores in order. So we'd start off with our 12s, list out all our 13s. Well, there was only 2 of them. List out 6 14s and so on, all the way through to our 21. But I'd have a string of 30 results, a total of 30 results. Now, trying to find the middle of 30, while it's manageable, it's getting on the big side. So that's where we see that the cumulative frequency actually helps us to establish the median, the lower quartile and the upper quartile from a graph, rather than putting our data into the calculator and getting the calculator to find for us the median, the lower quartile and the upper quartile. So, just a bit of revision about how we actually get this cumulative frequency column. I'm sure you will remember something like this, where the first cumulative frequency we get from the frequency. We then consider this number, adding the second frequency to give us our second cumulative frequency. We keep adding the frequencies. So as we list these 15s, we find we've got another 2 scores, which would take us up to a total of 11 scores. Adding in our 16s, and there were 6 of those, gives us a total now of 17 scores. So, as this is a stage 5 concept, I'm confident that you have all seen this process before for getting the values in the cumulative frequency column. However, if you haven't, then please make sure you ask me about it in class. Now, when we translate our data from our table to our graph, we get a nice visual occurring. You will know that you have successfully graphed cumulative frequency on this column if your graphs just continually rise. If your columns continually rise. You know that that's quite different. Most of the column or histograms you've drawn previously, the columns might go up and then they might come down, they might go up and come down, etc. That will not be the case. That will definitely not be the case with cumulative frequency. The columns must always rise. Your entries in your cumulative frequency column will always be getting bigger. And the very last one represents the total number of scores you have in your data collection. The columns are just called a cumulative frequency histogram, And again, we use the same guidelines. We'll leave half a column width at the beginning, and we put our score in the middle of each column and use appropriate scales on each axis and draw up the histogram. However, when it comes to the polygon, we construct it slightly differently. And you'll see down in the example here where the polygon now doesn't join the middle of the top of the columns, it cuts across the column, directly across, diagonally across the column. So please be aware of that. We're going to use this polygon or this ogive. Sometimes you'll see it referred to as an ogive. I'll just write that here for you. So cumulative frequency polygon can be referred to as an ogive. It can be used to estimate our median, our lower quartile, and our upper quartile. So we use the polygon to estimate these values. So the way these dotted lines are constructed are we take exactly halfway, exactly 50% of this last column. So you can see our last column went up to 30, and exactly halfway would be at 15. And since the median is the middle, then the middle of 30 in this case is 15, and we dot across until we hit the ogive or the polygon. The moment you hit the polygon, you come down and you read your score. So you could see that we would estimate the median to be this 16, and it comes from here. It's very important that you've got your polygon in the right position within the column. So please make sure you construct that accurately. Please use a ruler, and also use a ruler for these dotted lines. When we want a quarter or the lower quartile, Q1, then we want half of 15, which is at 7.5. And again, we would be estimating. So we dot across at 7.5, and we dot across until we hit the polygon, and we come down and we read off the result of 14 this time. So that's where your Q1 of 14 comes from. Likewise up here, we find 7 units, so we were up here at 22, and we dot across until we hit the polygon and come down and read it off at 18. And you can see that Q3 has been identified as 18. These are common questions on exams, and you are usually specifically instructed to use your graph to estimate the lower quartile, the median, and the upper quartile. When doing that, you must clearly show your construction lines on your graph. Do not rub them out, and make them very obvious. Dotted construction lines on the graph. Stop the video there and go through this example in another video.